Okay, so today we're going to talk about factoring difference of squares. So we are in our foldy notes again today. And we're going to start with the top. The M got cut off, so I wrote an M in. We're going to multiply and practice that first. So when you have a binomial and a binomial that you're multiplying, everything gets distributed to everything else. So we start with this x, multiply it times this x. X times x is x squared. Then I take this x times minus 6. So think of that as negative 6 because the minus is in front of it, which makes that negative 6x. Then we're going to take this 6 and multiply it by this x, which makes positive 6x. And the positive 6 times the negative 6, which gives us negative 36. Now, if you look at the original problem, everything was the same except this had a plus and this had a minus in the middle. And that's special. These are called conjugates. What it does is it gets rid of these middle terms. They are going to eliminate each other, and we are left with x squared minus 36.
That's weird.
It is kind of weird, but we're going to use that today to do our shortcut. So let's go ahead and take a look at the next one. So we have 2x plus 3 and 2x minus 3. The first terms are exactly the same. The second terms are the same except one has plus and one has minus. So when we multiply 2x times 2x, we get 4x squared. 2x times negative 3 is negative 6x. 3 times 2x is plus 6x. And then positive 3 times negative 3 is negative 9. So again, these middle terms cancel. They're not always 6's, but they will always cancel if you have this set up. And we get 4x squared minus 9. Now, if you look at both of these examples, what we ended up with was the first numbers, or the x times the x is x squared, and the 6 times negative 6 is negative 36. And so it's kind of like we squared the x and we squared the 6 and we put a minus between them. And this is where we're going to get the formula for difference of squares. If I have a squared minus b squared, you can factor it into a plus b and a minus b. I don't know why I'm boxing that. It's not exactly an answer, but we'll just go with it. And so what we're going to do on all of these today, they're going to be special cases where that middle term is missing. And we're going to write it as something squared minus something squared, difference of squares, and use this little shortcut that we just discovered. Okay, so let's go down to the examples. So on number 1, I have 81x squared minus 36. So 81 is 9 squared. So what I'm going to do first is I'm going to write this as 9x in parentheses squared minus, and then 36 is 6 squared. So now I know what a and b are for the formula. A is 9x and b is 6. And so I can factor it as 9x plus 6 and 9x minus 6. So all I have to do is recognize that that's a perfect square number and that's a perfect square number. And I should also point out this only works if there's a minus. If there's a plus in front of it, it does not work. Okay, so on number 2, the y squared is already written as something squared. And we can write 25 as 5 squared. So this is a difference of squares. We just proved it. So we can factor it into y plus 5 and y minus 5. And if we were to multiply this out, the middle terms would disappear and we would get y squared minus 25. Alrighty, so let's take a look at number 3, 9m squared. So 9m squared could be written as 3m in parentheses squared. Square the 3, you get 9. Square the m, you get m squared. And then 64 can be written as 8 squared. So what we're doing is we're trying to figure out what a and b would be from the formula. And if you cannot put it in this format, then the shortcut doesn't work. So I would just do 3m plus 8 and 3m minus 8. 1 plus and 1 minus. And technically you could do minus on the first one, plus on the second one. But I just always do it in this order. Okay, number 4 doesn't have any numbers and they're already written as squares.
So what's the answer?
So basically it's telling us it's just going to be x plus y and x minus y, except I started to write y minus 7, and I have no idea why. I think my brain was kind of looking down at one of the other problems at the same time. Alrighty, so on number 5, this is the one that shows up the most in your more advanced classes. I don't know why, but everybody who writes worksheets and textbooks is fascinated with x squared minus 1. You can write x squared minus 1 as x squared minus 1 squared. Remember, 1 times 1 is 1. It's pretty profound. And so we can factor that into x plus 1 and x minus 1. I swear I had to factor that on every calculus assignment all the way through college. I don't know why they're fascinated with x squared minus 1, but it shows up on everything. So memorize that one. Okay, so let's take a look at 6. How can I write 16 as something squared?
4x.
4x. Good. Squared. And then what about 49? 7 squared. Okay, so I've got 4x and 7, so I can do 4x plus 7 and 4x minus 7. We're almost done. So now I have x and y, but that's okay because I can write this as 9x in parentheses squared minus 6y in parentheses squared. So we're just going to have x's and y's in the answer, no big deal. So now that I've got that set up, tell me what goes in the parentheses.
9.
Good. 9x plus 6y. Good. And then 9x minus 6y. Very good. So this is just a shortcut. And then on number 8,
7.
this would be
7.
5. It's not 7. 5a squared minus 4b squared. And so we'd get 5a plus 4b and 5a minus 4b. And that concludes our lesson.